Good evening, everyone. Arif, I think we can initiate the session, right? Dr. Anup?
Yeah, I'm here.
Yeah,
Hope
good
I'm
evening.
Yeah,
audible.
we are just waiting for the expert to join. She will join now.
Yeah, right. Let's see.
Yeah, she joined. Yeah.
Hi, ma'am. Hi, Limna, ma'am. Hi, everyone. Dear global participants, a warm welcome from CTBC.
Hi, good evening.
Good evening. Good evening, everyone. Good evening, Limna, ma'am.
Good evening.
Yeah. So, uh, I coming to my designated job to welcome you all for today's expert session. That is what we call it. It is titled Mangroves, the key to ecosystem health. And everyone know that how the mangroves is actually working on, the ecosystem conservation sector. So led by Dr. LimnaMol V P. She's an assistant professor from Kerala University of Fisheries and Ocean Studies, what we call it is KUFOS, Cochin. We are delighted to bring together conservation enthusiasts, students, and researchers from around the world to reflect on ecological importance on mangroves. I think Dr. Limna Mo's works and insight will surely inspire and informed action towards preserving this vital coastal ecosystem will be a pivotal uh, element in this, dialogues. And thank you for being a part of this global dialogue on biodiversity and sustainability, especially on the key focuses on the mangroves. I'm, uh, you know, uh, over to Limna Mol. Uh, you know, thank you, ma'am. Yeah.
Thank you, Harris, for this wonderful introduction. So, once again, good evening to one and all present here. So, as Harris just mentioned, and my wishes and greetings on the occasion of World Mangroves Day. So, it's a great pleasure that CTBC has organized this event today in commemoration of the mangrove conservation. So, today we'll be looking at the varied aspects of mangroves. So, I think without losing much time, I shall move on to my presentation. So I'll be sharing my slides now. Uh, is this visible now? Hello?
Ma'am.
Yeah, are the slides visible now?
Yes, ma'am, visible.
And am I in the slide share mode? Is it come to full screen?
Yeah, it's okay, ma'am. It's fine.
Oh, okay.
So
Thank you.
I recommend the tech team from CTBC to record the session. I think you can initiate the recording. Yeah.
Okay, so thank you once again, and moving on to the discussion of today's meet. So the topic and the main area of focus for us today is mangroves, and my title is Mangroves, the Key to Ecosystem Health. So we shall be discussing on the varied aspects of conservation policies, practices, and community action, including the basic aspects and concepts of mangroves. And moving on to the introduction. So this very unique tree species, mangroves, it inhabits the intertidal ecosystem. So these mangroves, they are a group of salt-tolerant trees and shrubs, and they form distinctive forest ecosystems, and mostly in the intertidal zones of the tropics and the subtropics. They have a global distribution, but they are focused to the tropics and the subtropics, and they are characterized by a very unique habitat. As I mentioned, they are an intertidal ecosystem, and they have tidal inundations, anoxic soils, and fluctuating salinities to deal with. So they are a wonderful species which would stand all these extremities and come out clean. And coming to their global and Indian distribution, we have around 120 countries dotted with mangroves, and they lie between the 30-degree north and south latitudes, and approximately 14.8 million hectares are covered by mangroves as of 2020. The recent updates are yet to come in. The exact figures are yet to come in. And in Asia, the Southeast Asian countries host the majority of the mangroves, accounting for around 41.4%. And in India, as we all know, we have mangroves in Mumbai and Kerala, and the Sundarbans, the world's largest mangroves, are there in India along the Ganges Delta. And Godavari and Andaman Island, Nicobar Islands are some of the other mangrove areas of India. So these particular species, these mangroves, they have an n number of adaptations which make them able to survive in these intertidal extreme conditions. And a few of them including their tolerance to light intensity owing to their thick cuticle mesophyll and the hypodermis. And they can also withstand the UV light owing to their epidermis and UV absorbing phenolic molecules present in the mangroves. They are wonderful to deal with wastewater as they have the aerol barriers and the large parenchyma, which helps them filter out all these so-called pollutants, including oil pollutants, heavy metals. They can withstand flood due to their parenchyma and the lenticel and their waxy layer and the thick epidermis present in the mangroves. And again, same with sedimentation, their high ratios of phloem band and their growth layer, along with the increased vessel density, and all these features support their withstanding the sedimentation and the salinity. And again, they have a thick cuticle cell wall modification and hypertrophy of abaxial epidermis. These are all the few so-called their properties or their anatomical adaptations which help them turn into the so-called magical trees and with their multitudes of functions. So owing to all
Madam,
these features,
Madam,
yeah,
if I'm not interrupting,
yeah, please.
Madam, the slides are not changing, and can you put that in that full screen mode? Then that will be more visible, I think.
Sorry, actually,
Yeah.
from my side, it's in full screen mode. I think I'll get back again. 1 second.
Okay. Yeah.
Thank you on that. Let me
Yeah,
just
thank you.
try again. I think I'll try to share it in a different mode. 1 second.
Yeah, madam.
Yeah, please. Is my screen visible now?
Yeah, screen is visible, madam, but I think you just you can click that fourth option. I think right corner near that.
Okay,
Yeah,
that is
down that right corner, madam.
1 second. You mean this one?
No, like left that what you call, yeah, left uh, near that zooming now, left side to that zooming option, madam.
Okay, 1 second, 1 second. Got
Yeah.
it. I'll just
Yeah,
stop
that one.
pressing here. Yeah, yeah, this one, right?
No, ma'am, go right, madam. Wait. That one. There is an option like a cup like thing.
No, I don't have it here. Sorry. 1 second. I'll just stop presenting and I'll get back. 1 second, 1 second.
Yeah.
Let me just start it over again. Okay. Actually, I was presenting the entire screen. So I think the entire screen mode itself should be able to show, you know.
Okay.
Or let me just try the window now. I'll try the window mode. Maybe that will help. It's come on now.
Yeah, but still you have to click that. You can.
Yeah. I'm coming on to the screen, the full screen mode.
Yeah.
Let me just try.
Yeah, otherwise it is fine, madam. You can go with this mode also.
1 second. No. We'll rectify no issues. Make it okay and then proceed. Because it may not be legible otherwise, you know, if I am not in the full screen mode. I'm afraid a few of the, the finer details may not be legible. I'm on entire screen and here. So, is it visible now?
It's visible, madam. I think you can just click that. Can you see that?
It's in full screen, but
yes, madam.
my
No,
only
now it
worry
is
is,
correct.
but is it moving now?
Moving. Great,
Yeah.
madam.
Oh,
madam.
thank you. Okay.
Thank you.
So I think this introductory part we had discussed already. So their very particular salt tolerance and their unique habitat dotted with anoxic soils, their fluctuating salinity levels and tidal inundations, and the distribution across the globe, especially between the 30-degree north and south latitudes. And in India, we have the mighty Sundarbans, along with Mumbai, Godavari, Andaman Nicobar Islands, and Kerala also has its fair share of mangroves. So, is it moved? Has this slide moved now? Are we on the anatomical adaptations of mangroves?
Yes, madam.
Okay. Thank you. Okay, so let's continue. So, as discussed already, they have a huge number of anatomical adaptations, including their thick cuticles, their epidermis with UV-absorbing phenolic molecules, and their mesophyll area, their parenchyma, and the vessel modifications, and the thick hypodermis and palisade mesophills, which are all contributing to their adaptations in the intertidal environment. And now, these are huge complex species, the so-called mangroves, and they have a huge diversity also. Plus, again, they have critical ecological functions, which we'll be looking at in the next few slides. And they are the keystone coastal ecosystems. If you remove them, you're going to face a lot of issues, including the erosion and tidal inundations. And they are one of the most productive ecosystems in the world and provide numerous ecosystem services. So now moving on to their ecological functions, the sediment and nutrient retention is one of their major forte, and these facilitates the sediment deposition because they can hold on to the sediments and the nutrients are associated with sediments. So they form to be one of the most nutrient rich ecosystems. And again, they have a lot of role to play in shoreline stabilization. They prevent or reduce the erosion of the coastlines, and this is through the binding and stabilization with their intense root system. And they help in reducing the flooding. So if we have mangroves, we can be saved from the flooding issues and other inundations. And the groundwater discharge. This is another important ecological function of mangroves. These groundwater, when we have the high rainfall or when there is a water coming in through the rivers, they enter the mangroves and they are stored, or the disposition is delayed to the downstream area. So it acts as a water savior for us, or as a source of water storage system for us. And again, habitat protection and biodiversity. So both it provides food as well as shelter to the organisms. They are the crucial habitats for the life cycles of numerous plant and animal species. And especially for the plants, a particular mangrove may provide every element required to complete the life cycle of certain plant species. And they recharge our groundwater, as already discussed. And now coming on to the socio-ecological functions, they are again a rich source of biomass and productivity for the entire food web series. And they are a rich gene bank. They have a lot of biodiversity in them, and the genetic material, so the gene pool is preserved in the mangrove systems. And they're again very much famous for the recreation and tourism. We have mangrove habitats, we have waterways, we have the so-called boat safaris, and a lot of livelihoods are connected to this, making them a very important tool or element in the socio-ecological system. And again, waterways within the mangroves can be used for transport of passengers as well as goods for the local markets. And hunting and fishing is another socio-ecological function of mangroves. And the forestry products. The mangroves are a rich source of a lot of medicinal as well as commercial products of huge importance to mankind. And we have been dependent on them in the form of fuel, wood, charcoal, which of course is not so recommended one. However, dependency is there, especially for a lot of coastal communities, this is a lifeline. And now coming to their economic aspects with regard to their services. So they are a huge supporter of fisheries, more than 19 aquatic species in the Mumbai Konkan mangroves. They are using these mangroves for their breeding, and 6 commercially important species were identified through the DNA analysis. And Gujarat, again, the planted mangroves contribute to around 36.04 billion annually to the fisheries. So overall, around 23 to 34% of India's marine fisheries output comes from the mangrove habitats. And coming to the health benefits, so around 96 papers have documented the physiological health benefits. Actually, like all parts of the mangrove, their roots, the stem, the leaves, the associated organisms, the lichens, the fungi, all of them are rich sources of bioactive compounds which are being harnessed on day-to-day basis and giving us wonder drugs. And again, for heavy metal bioremediation, it's a wonderful capacity which is present in the mangroves. And of course, as discussed, the fisheries support and providing food security. And they are a natural barrier against erosion, storm surges, and tsunamis. We all know what happened in the 2004 tsunami. The huge waves lashed out on across the coast of India. And in our east coast, we have the mighty Pichavaram, the second largest mangrove systems in the world. And Pichavaram mangroves, they protected the entire area. The Chidambaram area was protected from the tsunami waves, while just south of that, the Kadalur region was totally devastated as they didn't have a rich patch of mangroves. Again, in 2024, we had the cyclone Dana, which had hit the Odisha coast, and the landfall was almost near to the Bitarkanika mangroves. And yet again, mangroves came to the rescue of the coast, and the Bitarkanika region was like saved to almost the 100%. There was minimal issues to that area thanks to the huge mangroves over there. So they are a wonderful barriers. They are the saviors of the coast in a way. And so rightly they are called as the sentinels of the coast. This is what a term which we often attribute to the rich mangrove ecosystems. They are indeed sentinels of our coastline. And they are living platforms which grow faster than sea level rise, giving us hope for our future. And they're very critical to Kerala coastline as well, as we are vulnerable to 1.75 mm per year sea level rise. So saving our mangroves is going to help us long time. Now, just a peek into the consequences of mangrove loss. So for humans, we know our provisioning services, our fisheries, food and clean water will be lost, our regulatory services, that's our influence on the climate, that is the climate regulation, the soil composition regulation, and the disaster risk. All these are going to increase if we cut down our mangroves. And our cultural aspect, including our recreational and spiritual space, will be lost. And as far as the planet Earth is concerned, the loss of biodiversity, the environmental degradation, coastal erosion, global warming, loss of livelihoods, and coastal wetland destruction. These are all the things we may face in the event of mangrove loss. And now this is the mangrove crisis, the global and the Indian perspective. So the 14.8 million hectares of mangroves is the extent globally as of 2020. But this is unfortunately only less than 1% of all the tropical forests globally. And in Kerala, we have faced a 95% loss over the past 3 decades, which is a very sad scenario. So the India's mangrove status as of 2023, so we can see here West Bengal is leading, followed by Gujarat, the Andaman and Nicobar Islands, Andhra Pradesh, Maharashtra, Odisha, Tamil Nadu, Goa, Karnataka, and then comes Kerala. Kerala has only 9.45 square kilometer remaining of the mangrove cover. So that's a small percentage. West Bengal is dominant with 42% of India's mangroves. So it's high time that we start conservation with a very serious note. And this is the extent in Kerala. So the major patches are in the Kannur and Ernakulam districts, and a few patches in the other northern Malabar districts. Down south, we have very few mangroves, and we have suffered some losses as well in the southern areas. So this is the breakup of the state and the year-wise breakup of the mangrove cover in our country. So the one good hope here is that we have a slight increase here, around 16 per square kilometers of increase has been observed as of 2023 as compared to 2019. So this is a good note for us from the India State of Forest report. So this gives hope for further conservation activities. And in the forthcoming slides, we will be looking at the huge effort that has gone into this minor change, or this mild change, or this mild positive note. So again, before moving on to these aspects, we will just have a quick look at the carbon sequestration, or the so-called nature's climate solution. Yes, mangroves are a very good sink for carbon. They sequester carbon 4 times more than the tropical forests. And India's mangrove carbon sequestration is 702.42 million tons of carbon dioxide equivalent as of 2020, and it is projected to increase to 748.17 million tons carbon dioxide equivalent by 2030. So that's a huge leap we are expecting. And coming to Kerala's carbon performance, the mean carbon ecosystem stock is 139.82 ton carbon per hectare. So this is equivalent to 513.13 tons carbon dioxide equivalent per hectare. And the one of the best examples of conserved sites is in Edat in Kannur, and the degraded sites again unfortunately falls in Kannur, that's Valapattanam. Valapattanam has a lush mangrove cover, but there has been a lot of degradation going on due to various activities, including the so-called urban developmental activities, which has taken a toll on these mangroves. And in Kochi, the historical sequestration rate is 2.95 ton carbon per hectare per year. So expecting for betterment in the years to come. And the few major threats and challenges. So the drivers of mangrove loss, of course, we all know it's one is the deforestation, or the cutting down for logging, the fragmentation and the clearance of mangrove forests. Though this is a major concern, though we are all aware of mangroves and its so-called good values, but the mangroves are being cut down on day-to-day basis, and agriculture replacing the so-called mangroves. The mangroves have been converted into rice paddies, and this is responsible for 88% of mangrove loss in countries like Myanmar. But unfortunately, in the so-called literate state of Kerala, also we can witness such activities going on. And aquaculture is also taking up mangroves, leading to almost half of mangrove losses globally due to shrimp culture. Then pollution is adding on to it, pollution by sediment, solid waste, oil, and the most or the largest menace now facing mangroves is the marine litter in the form of macroplastics. Microplastics is something we cannot visualize, but the macroplastics, and they are dumping them. If you go to any mangrove site in Kerala, majority of them will have a huge heap of garbage dominated by the large plastic bottles, milk covers, and so-called plastic garbage. So that's a very sad scenario, and it's high time we have to take action for that. And again, the coastal development. So this urbanization drives mangrove loss and degradation. In Kumbalam, in Ernakulam, which is very near to our campus, we were witness to one such activity. There was an extension of a railway station, and there was sedimentation, dumping of so-called raw materials, and including plastic refuse in the adjoining mangrove ecosystems. So such activities are going on day-to-day basis. And climate change, along with all these man-made or anthropogenic issues, there is the climate change, which is a larger extent of all our activities. So this is also causing abrupt changes to the sea level and resulting in the local and regional extinctions of the mangroves. So there are the primary threats, including land reclamation and urban development, and the climate change impacts, that is, of course, the sea level rise and changing precipitation patterns, the increased storm intensity and saltwater intrusion in the coastal areas, and the socioeconomic changes. So the private ownership hampering conservation, which is a major scenario or a major issue in Kerala as of today, and limited awareness. So such programs, if we take it to the field, if we take out, I believe we have quite a few audience here. So if each one of you go back and at least spread this matter, this awareness, you make at least 10 other people aware, that's going to take us a long way in our fight for the conservation of mangroves, because awareness is the key. Like, it is going to help us. And when we talk about awareness and initiatives, the government has taken a lot of efforts, we must say, because even the 16 square kilometer increase we saw is after a lot of efforts from the government. So the NISHTI, the Mangrove Initiative for Shoreline Habitats and Tangible Incomes, it's one of the flagship programs of the Government of India, rolled out by the Ministry of Environment, Forest and Climate Change. So this was launched on World Environment Day in 2023 with the objective to restore 540 square kilometers of mangroves across 9 states and 4 union territories of India over a period of 5 years from 23-24 till 27-28. So far, good progress has been achieved. 22,561 hectares have been restored across 13 states and UTs as of 2025. This is a very recent estimate. And 17.96 crores has been released for restoration activities. And Gujarat is again leading with 19,020 hectares restored at rupees 76 crores. So this is for the state of Gujarat alone, extra funding they have taken from the various organizations, and they have come up with this staggering achievement. So Kerala is part of the 6 states receiving the CAMPA funding, that is the Compensatory Afforestation Fund Management and Planning Authority. They are also funding the mangrove afforestation. And the focus areas in Kerala are Vembanad and Kannur regions, Vembanad Falls and Ernakulam districts. And distribution of casuarina seedlings and mangrove species is underway. So this casuarina, it was started long back, but today we understand that we may have to put away with casuarina as it is going to affect the groundwater level on a long term. So mangroves will be given more preference. The government is also taking a step in this direction. So this is the community-based conservation, the Kerala model. So Kalan Pukodan is very familiar, I believe, to many of you because of his long-term conservatory efforts for mangroves. And these are some of the successful community initiatives from Kerala are the Magical Mangroves campaign, where around 200 plus volunteers were trained and 27,000 plus citizens were sensitized. And again, the Mangrove Ambassadors program across the 7 coastal states, including Kerala, and ecotourism approaches. In Kerala, around more than 50% of the mangroves are under private ownership. So this is the biggest challenge we are facing as of now, because people, even though they know the value of mangroves, once when we visited Erakochi in Ernakulam during one of our field surveys, so there was an old man who was, he was swearing by mangroves that yes, they are our saviors. We know it. Because in the 2004 tsunami time, he said his family was saved just because of the mangroves surrounding his space. But at the same time, we had people who were like crying over mangroves. They were telling that these are like, causing our native plants to dry off. I mean, the native means their crop plants, like their mango, their coconut trees, were all drying off because of, they claim mangroves are also one of the reasons, but the major reason actually was the sedimentation or the siltation, which was very much prevalent in the Vembanad Lake system. So the people are divided on this account. So when it's under private ownership, it's a huge task to make them aware, to convince them to conserve the mangroves. And these private owners, they lack the direct economic incentives also, so which is another challenge. It's like a hurdle on the challenge. And financial incentives around 4,000 per hectare annually for mangrove preservation is the present rate, and the Mangrove and Marine Biodiversity Foundation has been established, and the government is willing to purchase the private mangrove lands. But here again, there is another huge challenge in the phase of in the form of displacement. So people may get displaced. So that is another concern for them. This especially applies for the small islands. In Kerala also, we have a lot of small island formations along the coastline where they are rich in mangroves, but when the government wants to purchase these private mangrove lands, the people fear displacement and they start, there is a sort of disagreement over this. So one initiative which the government has successfully brought forth in Kerala is the Kadalundi Vallikundu Community Reserve. This is in the bordering Calicut and Malappuram district. So this is a very huge extent of mangrove, around 153.5415 hectares. And it's on the Kadalundi River. So this is a very good example of mangrove conservation with community participation. And other state-specific initiatives are the once by the Kerala Forest Department in Kannur district. And the challenges in implementation, yes, we have the land ownership as the major challenge, then the enforcement gaps. So we all have the coastal zone regulations. The 2019 regulation is in place. However, a lot of violations still persist due to development pressures. So that is another challenge. And again, there is the conflicting interest, as I just mentioned, especially in case of so-called islands, the balancing conservation with livelihood needs and development. That's a huge challenge which the government is facing. But we have some good initiatives like the Kerala Forest Department's Thiravanam project. This focuses on mangrove conservation and afforestation. Then the Kerala State Biodiversity Board, they have developed the Strategies and Action Plan, SBSAP, the State Biodiversity Strategies and Action Plan 2022 to 2032, a 10-year program with a vision to protect and sustainably use biodiversity, including mangroves. So some of the protected areas along Kerala are Mangalavanam in Ernakulam, the Kadalundi Vallikundu Community Reserve in Calicut, the Mangrove Islets of Chetua, that's in Thrissur. These are few of the protected sites. So Mangalavan was declared in 2004, and it's a rich mangrove sphere we have here in Ernakulam. Now coming to the few policy framework and the regulatory measures which we have in place. So the CRZ Coastal Regulation Zone Notification 2019 is the apex regulatory framework we have as of today, and wherein 50-meter buffer zones are identified for mangrove areas more than 1,000 meters square. And there is a 3:1 replacement ratio for any mangrove loss, and this is protected under the Wildlife Protection Act 1972 of the Indian Forest Act 1927. So this is the image prepared by NCSEM Chennai. They are one of the authorities on wetlands, including mangroves. So this is just the map where, you can see the area, the green areas bordered by red are the mangroves, which falling in the CRZ 1A. So they all have these buffer zones also associated with them. And the other CRZ zones are also visible in this image, CRZ 1, 2, 3, and 4. So these regulations are very strong. The only thing or the only challenge which remains is that they have to be followed without violations. So violation of CRZ 2019 is the biggest challenge we face with regard to conservation or with regard to the regulatory measures. And the promotional measures. Yes, so we have quite a few promotional activities, including the Conservation Management of Mangroves and Coral Reef Scheme, the National Coastal Mission Program. We are lucky enough that the program is finally getting rolled out. So this is going to conserve our coastlines, including the mangroves, on a large scale. And there is a 60-40 cost sharing between the center and the state governments. And rupees 8.58 crores was already released to 7 coastal states as of 2020 and 23. And the specific policies to Kerala, they include the exclusive mangrove forest conservation laws which have been recommended. The site-specific restoration programs are emphasized. We have to identify the sites and frame the programs, because even though we have a small coastline, it's only 590 kilometers long, but the ecosystems are very varied. We have mangroves coming in very close proximity to the estuaries and the wetlands. So that makes it a very complex system. So the recommendations need to be site-specific with a lot of studies and research going into it. And the most important aspect, integration of the GIS and remote sensing for the monitoring studies. So as we have already seen, Kerala's mangrove biodiversity is a treasure under threat. Yes, we have quite a treasure here. And the major concern is that we have already suffered a 95% loss from our historical 700 square kilometer to the current area, which is less than 50 square kilometers. So Kannur has and Kasargod, they are they're having a good status on the conservation regime, and followed by Malappuram and Alapura, which are in a moderate status. And Calicut and Ernakulam are on the poorly conserved status, and the critical habitats in Kerala are in the south, especially in Kollam and Tirunelveli, with a few areas in Thrissur as well. So this is our status as of now with regard to our conservation. So let's move on to the better side of it, or the ones which give us hope. That is our remote sensing and technology integration. So the monitoring technologies, including the machine learning algorithms, the satellite imagery analysis, the multi-decadal land cover change analysis, and the mangrove health index are few of the positive notes or the positive aspects which are being included into the mangrove studies as of now. And the applications in Kerala include the GIS mapping for the identification of scattered patches, the remote sensing for area estimation and monitoring, and the development of vegetation indices for the health assessment of mangroves. And we have a few data gaps, of course. One is the scarcity of scientific information in many of our districts. Like the information we have are patchy. We have information, but only from very small patches. We need a wholesome, integrated information for us. A database is required to be developed, and there is a need for standardized monitoring protocols. Like every institution which studies may be doing on its own terms. That won't suffice. We need a standardized monitoring protocol and integration challenges for multi-source data. These are few of our issues. So coming to our restoration techniques and the best practices. So here we can see an afforestation procedure here on the right side, the collection of seeds, their propagation, the preparation of the area of afforestation, the plantation of the seedling, and their relocation. So all these need to be done with a very good scientific background. It should be studied scientifically, and only then we should go in for the so-called mangrove afforestation. A very good example of a region with mangrove afforestation and a success story we can call is from the Malvan region, the Sindhudurg district of Maharashtra. It's just north of Goa. So this area we can see a wonderful mangrove afforestation program in place. This was initiated by, excuse me, I think there is a slight disturbance. I doubt somebody is unmuted. Harris, can you please check on that? I can hear a small continuous.
Yeah, madam. Please, I request everyone to mute.
Yeah, thank you. Okay, so moving on. So this Malvan in Sindhudurg district is a wonderful example. So there actually the program was started by United Nations Development Program, and then there was a wonderful hand-holding with the so-called self-help groups. They have a women's group there, similar to our Kudumbashree in Kerala. So they have taken active role in integrating the mangrove and the aquaculture practices over there in Malvan. So it's a wonderful success story. So similar stories can be replicated in Kerala and other parts of the country as well. And another best part of Malvan is their waste management. They have a very good solid waste management plan in Vengurla district. So it's worth a visit if any student volunteers or CTBC. You can sometimes plan a visit to Malvan, Vengurla and the Sindhudurg district. So that's a wonderful initiative which we can try replicating in other parts of the country and Kerala. So moving on to other restoration techniques. So we have this community-based ecological mangrove restoration, that is the CBEMR, and community empowerment through the restoration cycle. So there is unfortunately an 80% failure rate of the conventional planting projects. See, the major issue is site selection. So what we have seen is not only in Kerala, across India, they go and plant mangroves in mudflats. So mudflats, they have their own ecosystem. It's not that if it's a mudflat or a muddy region, you can go and plant your mangroves. No. Mangroves have their own specific intertidal regimes, which needs to be identified with a proper environmental assessment. That is what is lacking in our approach, and that leads to failure of the conventional planting projects. So when we have a scientific angle or a scientific backbone is rendered to such studies or such initiatives, ultimately we are going to get success. And in Kerala, we have again a few success factors. When we speak about failure, let's look at the few success factors as well. So one thing is the local species selection. So if we focus on the native varieties, yes, that is going to help us in the long run. And freshwater supply restoration, tidal flushing enhancement. So another issue we see is the clogging of the tidal flushing units, or the so-called small channels or canals along the coastline. These have been clogged, sometimes anthropogenically for the personal requirements or for their personal development, or otherwise due to natural causes. So So when the tidal inlets are clogged and there is no proper flushing, the exchange during the high tide and low tide is affected. So this is again affecting the mangrove species and their health. So a community-based management through ecotourism is another success initiative which we can try. So the technical approaches include mangrove nursery development. So again in Malvan, they have a wonderful mangrove nursery, which is also tended by the SHGs or the self-help groups. So the site-specific restoration plans and integrated coastal zone management. This is going to support us in all our restoration activities in the long run. So again, moving on to the research priorities and knowledge gaps. So the critical research needs of today, they are the long-term field observations for carbon sequestration under elevated carbon dioxide scenario, species-specific responses to climate change. Each species may like react in a different way. So this has to be studied. And the in vivo efficacy studies of mangrove active compounds. So as we saw in our initial slides, they are a wonderful source of active molecules. So this also needs to be studied and research needs to focus on this. Few activities are going on even today, but we need more focus on this area. And the nutrient content analysis of the mangrove supported food products. This is another aspect which can be studied or researched. And the methodological advancements, we need to go into the molecular aspects and isotope studies for tracking and a comprehensive evaluation for ecosystem health assessment, machine learning for vulnerability mapping. So here this machine learning and the GIS and spatial tools is going to take us a long way if we focus on this, because that is going to give us a lot of technical advantages in studying these wonderful complex ecosystems. And for Kerala, if we look at the specific research needs, yes, we need a comprehensive species inventory across all the districts. We have inventorized the mangroves, but that is not foolproof. So this has to be done on an urgent basis. And a carbon stock assessment in the different mangrove types. So there are different types of mangroves where a type-wise carbon stock assessment is also required, and economic valuation of the ecosystem services. So we have seen in our initial slides that there are a lot of ecosystem services, but this is not quantified. So we have to carry out a proper economic value-based assessment of these ecosystem services and the community perception studies on conservation. So see, from these 4 points, we can see that this is a multidisciplinary approach. This calls for a multidisciplinary approach from the social scientists, from the academicians, and from the so-called management sector. So everyone has to put their hands in so that this can be a success story. And the key performance indicators, which we can, a few of them, which has, see, when we say that this has to be done and that has to be done, we have to, of course, acknowledge what has already been done. So the few indicators, we have the MISHTI program. So this has restored around 22,561 hectares across 13 states. And Gujarat is leading, and the investment efficiency is 94 crores. And the carbon economies. So in Kerala, 139.82 ton carbon per hectare is the sequestration rate. And 35% higher carbon is conserved, whereas compared to the degraded sites. So that's a positive note. And on a national perspective, 702.42 million tons of carbon dioxide equivalent has been stored. So these are, a few of the positive things or the successes we have obtained or we have achieved. So what is required is CAA for the community action framework. Now, to take this to the, the larger sphere. So in government agencies should of course be there. Only then the so-called multidisciplinary or the multi-stakeholder engagement will help us. The forest department and the coastal zone management should be going hand in hand. And academic institutions, they have a long role to play. Already Cochin University, Kerala Agriculture University, they have been working on this for a long time. KFRI, to name a few institutions. And now KUFOS has joined the league with a few of our studies over the past few years. We have been actively involved in mangrove-related studies for conservation awareness and on the greater scientific aspects. NGOs like WWF India, the Kerala Shastra Sahitya Parishad, they have been involved, and CTBC has taken a wonderful initiative. They have come forward for the mangroves, which is a great thing. And along with this, we have a few private sectors like Godrej and the Boise partnerships, and the local communities. From the likes of Pukoden, we have other fishermen, farmers, and the coastal residents who are playing a good role and who have a larger role to play. So the action strategies are, of course, the education and awareness. Mangrove Ambassador Program is one thing which can be done. Then ecotourism development, the PES schemes, the CRZ enforcement, restoration funding, and technology transfer by mapping the GIS. We can do a public technology transfer. We can create, so-called web information systems which can be accessible by the local public. So it is one initiative. We are focusing on our laboratory as of now through my student, Mr. Setu. So through the PhD program, we are working on this web information system development. And university community partnerships, yes, this through one of our outreach programs, this is exactly what we are focusing on. And at present, on August 1, we'll be rolling out a program for Women in Ocean Science campaign, and mangrove areas are going to be one of our major focus. Then the other case studies from India and Kerala. So we have awareness programs already conducted by organizations like the Commonwealth Human Ecology Council in Kerala. So this involved farmers, fisherfolk, and students. Then other community-based conservation initiatives and promoting the responsible mangrove tourism for providing alternate livelihoods. So these are all the community action framework. And the few before moving on to the activities, the particular activities of KUFOS, we'll just have a quick look at the future roadmap and recommendations. So short-term actions. So we can have the short-term, medium-term, as well as long-term visions. Short-term is for the immediate 2 years. One thing is, of course, completing Mishti Phase 1. So this will target around 540 square kilometer restoration. And we can immediately strengthen Kerala's participation in the national programs. Then one thing we can try to do is establish mangrove research stations in the key districts. So we have seen that we have very good patches in Kasargod, Kannur, Kozhikode and Malappuram, and Thrissur, as well as in Ernakulam. So at least in these districts, we can establish mangrove research station. And one, of course, is required in the southern districts of Kollam or Thiruvananthapuram, as we have some critical issues there with regard to the mangrove ecosystems. Then we can develop the community-based monitoring systems and create economic incentive mechanisms for private landowners. But this is a huge challenge. This may have to come from the higher levels of the government and the policymakers. That is the incentive for the private landowners, as more than 50% of mangroves in Kerala are under private land ownership. Okay, now moving on to the medium-term goals. That is, maybe we can target for 2027, 2030. So we can think of doubling Kerala's mangrove from the present 9.45 to approximately 20 square kilometers, which will be a wonderful leap for us. And we can achieve carbon neutrality in the coastal districts. Yeah, this is one thing we can try to achieve, carbon neutral districts along our coastline. Establish mangrove-based ecotourism circuits. Yeah, we have few mangrove tourism, but proper eco trail circuits are not there, which can be developed, and develop blue carbon markets for the coastal communities and create mangrove biodiversity corridors. So these are like we have the so-called green corridors in. We have one here in Ernakulam district. We have a green corridor that is in the Ernakulam and Thrissur bordering districts. But we do not have any mangrove biodiversity corridors as of now. So this so-called green corridor is near to Adrapalli. It was developed as part of the United Nations Development Program project on the high range mountain landscape. So similar initiatives for the mangrove biodiversity can be, we can try to replicate such activities for the mangroves. And again, coming to the long-term vision, yeah, the 2030, 2050 targets can be restoring the 50% of our historical mangrove extent. So we had 700 square kilometer. So we can think of achieving a 350 square kilometer target. That will be a huge achievement for us that can be targeted for 2050. And we can integrate mangroves into climate adaptation strategies and develop sustainable coastal livelihoods for around 1 lakh plus people and establish Kerala as a model for mangrove conservation. So this is going to contribute to the global mangrove restoration target as well. So now here are so after looking at all these perspectives or the importance of mangroves, what can be done, how can be done. Let me just present before you a few things which we have been able to do, or a few initiatives, both academic as well as the research perspectives which we have done. One is a health assessment was carried out for the Indian mangroves with Kadalundi Community Reserve, the Kadalundi Vallikundu Community Reserve as a case study. So this was carried out, and we found that there is a strong pressure on the coastal environment by pollution, habitat destruction, and fragmentation, as well as overexploitation of the natural resources. So here an integrated approach was taken up, and we have brought out a methodology which can be applied to any mangrove forest of India. So this is the core model of our study. So the selection of study site, the region-specific selection of indicators, data collection, the metric system for each indicator will be developed, evaluation of the present health status, and we will link this to the conservationists, that is the adoption of best conservation strategies, and then of course, this is the key aspect, the constant monitoring. So if this model can be applied for any mangrove system to assess its health and bring out the perspectives. Another study which we could successfully bring in, or this is another, what is it, the so-called machine learning which we applied, and the spatial tools. Here we have used RPAS, that is the remotely piloted aircraft system, or in simple terms, a drone was used to study the distribution of mangroves in a specific area of the Central Inland Lake system. So here we obtained a better coverage. So unlike other satellite data, using the satellite data, here using the drones, we had better pixel resolution. So 0.84 inches per pixel could be very clearly observed and studied. So this has given a very good lead for us with regard to the monitoring studies. So as we saw in our previous roadmaps, this monitoring using spatial tools is, and here especially using other machine learning accessories, is a great achievement for us. So now this can be replicated. So here we have developed an algorithm for this. The methodology has been fine-tuned, and now this can be applied for other mangrove systems as well. So this will help us to keep a constant check. We can know whether it is getting patchy, whether fragmentation is there, or whether fresh patches are developing. All these can be monitored on a day-to-day basis. And these are the few studies which have carried out on the biodiversity. As we know, there are a huge diaspora of flora and fauna associated with the mangroves. So we had a few documentations along Kerala coast, and we could record a lot of crabs and other molluscan species and fish species, including gobids from the mangrove habitats. This shows their rich biodiversity and the need. As we all know, the urgent need to conserve these beautiful sprawling habitats. And as part of our ongoing studies, we have a good project funded by the Department of Environment and Climate Change. This is on ecological resilience indicators for coastal ecosystems along Kerala coast, and with special focus on the mangrove ecosystems. It's a 3-year project. So the relevance we are going to focus is, one is the mangrove cover, the community participation, the climate change resilience indicators. Because see, we all know that climate change is already set in. So now the idea remains as to how we can withstand it. How are we going to withstand the climate change? And so for that, we have to identify the features which can withstand them, or the organisms which can withstand this climate change. And mangroves are going to be a wonderful habitat to study this so-called resilience. As we have already seen, they are a very sturdy habitat. They have a lot of adaptations. So the resilience, the signatures or the key to resilience will surely be hidden in the mangrove ecosystems. So with these, we are going to develop the Coastal Resilience Index and bring out an ecosystem services assessment as well. So the outputs of our study will be the biotic and the abiotic indicators of the resilience along Kerala coast, and we are also going to develop baseline data for the climate resilient ecosystems, as well as an upgradable online atlas using the WebGIS for public awareness on the important coastal ecosystems of Kerala. And here mangroves are going to be a large part of this of our outputs. So the conservation of this complex and dynamic coastline is our major objective and output. And this is another thing we have in mind, that is the development of community involved conservation regimes using the resilience indices which we will develop using with this project. So this is going to be it's a project spanning 2024 to 27. There's a 3-year program. So our first phase of sampling is done. So we have got some clues now, and it remains for us to develop these into actions during the next 2 years and into suggestions for the policy frameworks. So our motto is to involve people participation and enhance the local tourism. As we have seen the ecological and socio-economic aspects, it should go hand in hand. Only then conservation can be materialized. So we have this call for action. And based on whatever we have discussed till now, there are 4 aspects to the call for action. One is for the policy makers, because they have to strengthen the enforcement of CRZ regulations. Because only if we have the CRZ regulations in place, we can support the policy and the ecosystem. Increase funding for community-based restoration, develop mangrove-specific legislative frameworks, and integrate the ecosystem services in coastal planning. Then for the researchers, yeah, we need to have long-term monitoring programs. We need more and more innovative ideas for monitoring, and we have to develop climate resilient restoration techniques. Then study the community ecosystem interactions, because if community and ecosystem can go hand in hand, we can have conservation as well as development on the same scale. And this is what we need to achieve. And create decision support tools for managers, because as we saw, it's a multidisciplinary approach. So everybody has to have their own role, and they have to act their part. Only then we can achieve these initiatives. Now for the communities, yes, before that, for the organizations, we have to invest in the blue carbon projects, support the community conservation initiatives, partner with research institutions, and develop the innovative financing mechanisms. And for the communities, we have to participate in the mangrove ambassador programs. When we say the community, it starts from like it can go from the if you take the students from the kindergarten to the school to the colleges, the local communities. Then we have the stakeholders, the so-called middlemen in various activities, various factories, industries. Everyone has their own role, and it goes on till the so-called authorities. So we need a participation from each one. And when we take up the mangrove ambassador programs, it can be the students and the local communities which can play a great role in this. And we have to support the ecotourism initiatives, practice sustainable fishing methods. So here we can see that all the SDGs have a wonderful role here. So this mangrove and its conservation regime, or the so-called mangrove program, we can put it, is one area where SDG, all the 17 SDGs, including our SDG 14 with a larger role, that is life below water, and SDG for food, health, gender parity, every single SDG can fit into this particular mangrove program. So that's another good part of it. And monitor and report the mangrove health. Yes, this is the most important part which communities can do, as this is a labor intensive process, but it is going to surely give its wonderful product to us, or the so-called results are going to be great. So together we can restore the guardians of our coast. So this is the message for us. It's for me and you, all of us. Let's take this message into our stride and continue on our path towards the restoration and conservation of this wonderful ecosystem, the mangroves. So these are the few key areas where research is ongoing, or the few major references. So that's all from my side. Thank you one and all for the patient
Yeah.
audience.
Thank you, madam. It was
Thank you.
very insightful and engaging, and it was really enriching. Yeah. So now it is open for discussion, and Mr. Sedu will mediate that. Sedu, please take over from here, the discussion part.
Yeah, sure. So yeah, first question is from Krishna Kanta. He's like asking, what is carbon sequestration? Hi, ma'am. I'm audible.
Yeah, you're audible, Setu. Please carry on.
Oh, So Krishna Kanda is asking what is the carbon sequestration and what is the CO2e and CO2e per hectare.
Okay, thank you, Krishnakant, for the question. So, carbon sequestration is the storage of carbon. So, what happens is not only mangroves, any photosynthesizing plant for that matter, they captures carbon. The environmental carbon is captured, the carbon dioxide is captured, and it is converted into the biomass. So, in this process, there is the sequestration activity going on. So next is when we say the CO2 equivalent, it is like not alone carbon dioxide, all the gases in the atmosphere are trapped in this process. So that's why because when we measure, we cannot measure the CO2 alone. What comes is all the environmental gases there. So that's why it is known as the CO2 equivalent. So I hope the answer is met.
Yes, ma'am. So
yeah.
moving to the next question is from Manisha Bera.
Yeah.
So she's asking, can mangrove planting serve as a solution in salinity affected areas?
Yes, a mangrove can definitely act as a solution in salinity affected areas because the best part is that mangroves, one is they are highly salinity tolerant. They are a haline species. They can tolerate wide extents of salinities, wide range of salinity. And another thing is, as we saw in the initial slides, they have this property of filtering out. So they can, like, whatever groundwater reserves you have, they can be stored and purified by the mangroves. So this is the second aspect of mangroves. So they are definitely a long-time solution to the salinity affected areas.
So next question is Ashudit K. Babu. So his question is, mangroves act as a breakwater between sea and land along Indian coastlines. Is it?
Yes, mangroves act as a guardian for the coastlines actually. So because they are found in the estuarine regions. So what is happening is when there is too much of storm surge or seawater inundations, mangroves act as a barrier because of their wonderful root network systems which they have. It binds them to the soil is bound, or the sediment and the substrate are bound to the mangrove roots, so that there is a prevention of erosion, and the natural calamities can be kept at bay. And as we have seen with the examples of Pichavaram during the 2004 tsunami, and more recently Bitarkanika mangroves was the savior for the particular Odisha coast during the Dana cyclone in 2024. So they are indeed, like, the barriers, or they act as the sentinels. More than barriers, it would be wonderful to call them as the guardians or the sentinels of the coastline. Yeah.
So yeah, moving to the next is Colin Philip. He is asking, do mangroves affect nearby cropland, and how can any negative impacts be prevented?
Yes, this is for this. Yeah, we have an example from real-time scenario also. So this, thank you for the question. This is one doubt which many of the local communities or the coastal communities have in their own mind, because mangroves are, they spread very fast. They are very strong, sturdy, adaptive species. So like any adaptive species, they can, spread fast as well. So a few of the coastal communities have this concern that mangroves are drying off their crop plants. But this is not true, because mangroves grow in their own regime. They grow in the so-called, moist, loamy soils. And if you have your crop plant nearby, their drying need not always be caused by mangroves. It could be due to various reasons. And in a field visit to Kumbalam area, what we saw was this drying up was due to long-term siltation. So siltation was increasing the salinity of the area, and this was drying the crop plants, unlike mangroves. So they are not a threat to the crop plants. And another thing we have to actually see is that mangroves grow in their own habitat. So how crop plants came there is the first question. It is obviously mostly there might have been a deforestation and cropping of plants. So when the mangroves try to regain their natural ecosystem, the crop plants may suffer a loss. So this is actually a retaliatory process. But yeah, of course, when we think from the perspective of the particular farmer, he may be thinking only about his crop plant. And this is exactly where we need incentives and afforestation drives, because only if government and policy makers intervene can can we have a solution to this scenario where the farmer will always try to protect his crop plant, which once might have been a mangrove land, and that's why the mangrove is growing there in a lush manner. So there, the only way out is to give an incentive and go on with afforestation of mangroves rather than fighting against the mangrove and destroying them.
Okay, ma'am. Now moving to the next question, Carmila. Carmila is asking, are there any specific initiative taken by West Bengal to conservation of mangroves in that area?
Yeah, West Bengal, the success story of West Bengal is with their, the main aspect is the successful implementation of the coastal zone management program in West Bengal. The ICZM has been initiated. The integrated coastal zone management was successfully initiated. West Bengal is one of the states where it has been successfully initiated and applied. So it has been successfully completed there. So with that program, a lot of support was given to the coastal development, including mangroves. The another part is, see, we have the Sundarbans there. So Sundarbans is giving the major chunk of, or it's giving West Bengal the major percentage. But if you take a state which is rapidly growing with regard to conservation is Gujarat. West Bengal has its natural resource, which is conserved, but the growth percentage is not as high as Gujarat.
Yeah, that is well explained. And moving to the next question by Helly Oswala. So the question is, in your presentation, you mentioned that Gujarat mangrove cover has reduced by 12.94 square kilometer. Could you please share that might be the possible reason behind the decline? Are there specific factors due to which Gujarat is lagging behind in mangrove conservation?
No. Gujarat actually overall there was destruction like Kerala, but recently they have come up. Like there was a decline, yes, due to various activities, including the coastal development, urbanization, etc. But the best part is that after that downfall, they have now come up. Now they are through the Mishti program, Gujarat is taking a long stride. There has been substantial increase in the Gujarat mangroves.
Okay, now moving to the John Tika. So he was giving a warm regards to ma'am for taking this session as an importance of conservation of mangrove from Kenya. So he's a conservation specialist from Kenya.
Okay.
So, and moving to Hridya. So she's asking how mangrove conservation and ocean acidification connected.
Okay, so the ocean acidification, we all know that because of this so-called increased greenhouse gases, we have the the pH reduction in many areas. So this ocean acidification actually affects corals more than mangroves, but mangroves are not alien to this. So like any other ecological issue, ocean acidification has its toll on mangroves, but they do withstand it better than the corals. So it is not something as compared to the deforestation and other pollutants like the plastic and the marine debris. Ocean acidification is somewhat, they can fight against it. But on a larger note or on a larger scale, it is going to affect the mangroves as well. They are very sturdy and adaptive, so they can withstand to some extent.
So there is next two question from Om Vaidya. So he's asking that the biggest emerging threats to mangrove ecosystem and how should we prepare to address them?
Okay, the biggest emerging threat is urbanization and the associated pollutants. So when we say urbanization, the pollutants are not all we can see. So we have plastic. Plastic is one of the major pollutants arising out of urbanization because what was once the suburbs are all now becoming urban areas. Then another thing is the so-called urban jungles or the concrete jungles. So they are also going to, affect the mangroves because when the concrete jungles grow, the mangroves are pushed back. But the irony is that mangroves are actually the cooling gradients. They are the ecosystems which support our urban areas. They help them in, minimizing the temperature spikes. But without realizing that, we are pushing them off. And then, of course, the other pollutants, including the sewage, septage, all of these are going to add on to mangroves. they're going to add on to the impacts on mangroves. Yes.
Okay, ma'am. So moving to another one is Aman Khan, and the same person is asking how the remote sensing and AI is helping for the effectiveness of conservation practice and the same time nitrogen fixation for soil. So these were the two questions.
Okay. So, with regard to AI and the remote sensing, so these are actually helping long term in monitoring. So now with advancement of spatial tools, like we can go back in time, and we can have a data say around up till around 10 to 20 years back. So we know what was there, and present day we can go and study them, we can map them, plus go and visit and do a validation of the present day scenario, and the future we can develop models so that we can see that yes, this algorithms or models can be developed for better conservation. And another thing is the monitoring. As I mentioned, the ARPAs, or the remotely piloted aircraft systems, as the drones, they are going to play a huge role in the future of mangrove monitoring, because they give us very good resolution, 0.84 pixel per square meter, as compared to the satellite data, and that's a wonderful achievement which we could personally achieve. So that's again thanks to Setu and his research associates that we could realize that. And again, coming back to nitrogen fixation, yes, again. So with regard to with these data, we can look at the aspects of conservation and soil fertility, especially with regard to the agriculture regimes. So we can look at the afforestation, deforestation perspective, or the agricultural plantations and the so-called mangrove area. So based on these, we can link this to the nitrogen reserves. So this is also going to give us an idea regarding whether the mangroves have been cut down or afforestation is in place.
Yeah. So, thank you, ma'am. So the Anand, somebody from Anand, like Anand Chaurasia is asking, raising hand.
Okay.
So you can ask to ma'am. Anand, I think he gone, and but he write it here like, yeah, he's asking. Yeah, thank you.
How does nutrient cycling occurs in mangrove ecosystem despite poor soil aeration?
Okay, so the nutrient cycling occurs in mangrove systems because of the rich biodiversity. That is what is supporting the nutrient cycling in the mangroves, because we have a very rich cycle of organisms there, and again we have the microbes. So there is poor aeration, yes, but there is a rich flora, microbial flora is there, which is acting long term in the degradation of the organic matter, and again the cycling is continuing over there. So it is due to their rich and fertile microbial flora that the nutrient cycling in the mangroves is supported on large scale.
Okay, ma'am. Thank you.
Okay.
So, Abhishek, he wrote and he raised the hand. If you are available, please ask to ma'am. I will read out the question, ma'am. So, is a mangrove improve or develop their adaptation process, and is mangrove able to become as a sport cultures?
Pardon? Can you please repeat? Is mangrove able to?
Is mangrove improve or develop their adaptation process, and is mangrove able to become as for sport cultures?
Okay. So yes, see, that is exactly what we are also trying to look at, whether they are like developing their adaptive prowess, that is, whether they are becoming resilient to the so-called climate change. So it depends on our study. Like we have just initiated the study, so maybe in the next 2 years we will be able to come up with an answer to this, because that is a big if in front of us as well. If they come out, true in this resilience regime, then that's going to be a big success for us. It's yet to see.
Deepak, you are asking, Deepak, if you are available, you can ask. I think a few more questions are right here. Like, so I will read out the same question.
Okay.
So, we are Carbon Project Development and a Climate Advisory Service company named Sequestra,
Okay.
led by a 19-year-old. Is it possible or better way to indulge in projects as a mangrove restoration or building hectares of mangroves as an initial pilot project along with NGOs or government of Kerala? How can that be done? So
Yes, yeah, and that's it's nice to see that youngsters are into mangrove conservation. Yes, definitely. What you should do is handhold with a government agency. As you know, I mentioned during our presentation, site selection is a very important aspect. It should have a scientific background and backdrop. Only then it is going to help us in the long term. Otherwise, we will plant and it need not always grow. Planting is easy, but growing and sustaining is a different game. So definitely you should do a hand holding with the government agencies. That will be the best thing to do.
yes. So Muhammad Anas have a question like allelopathic effect. Tell about an allelopathic effect and what their reproductive output. What are the practical difficulties of tissue culturing of mangroves?
Okay, tissue culturing is like not something which has been much pursued. Maybe I will not say that it is not possible, but presently the growing of seedlings is what is being focused on. But for seaweeds, we have tissue culture. We have the laboratory specialized for that. So maybe in the long term, in the immediate future, like yeah, tissue culture can be thought of, but their conditions are very specific. Germinating a mangrove seed is not an easy game, and we can see that they have very they will not allow another species to overgrow them. So they have this very strong allelopathic properties also. So growing them in the lab may not be a very easy job, but yeah, if somebody is very see, these are all future research areas which can be taken up by youngsters. So maybe it can be taken up as a challenge by somebody out of interest. Otherwise, seedlings, growing seedlings is the norm as of now, and then transplanting them to the specific sites.
So Gopal Pandey have a few questions. So Gopal, you can ask to ma'am. Gopal, are you listening? I think yeah. So he wrote a few questions, ma'am. Actually, one of them I can read out is like the temperature of seawater which is increasing due to climate change, can it affect the mangroves? And the second question of him itself is uh yeah, the same one he wrote two times. Yeah, the temperature of seawater which is increasing due to climate change, can it affect mangroves?
Let me just try to answer that first. See, seawater temperature, yes, it is increasing. That's true, but that is not like a huge increase. So we are having a difference of around 1 to 2 degrees, which again is not too much felt in the estuarine realms, because in the estuaries we have a mixing of the riverine and the marine systems. So that is somewhere an area where you have tidal inundations, the high tide and the low tides are there. So, due to these factors, the so-called temperature rise is not much felt. And as of now, mangroves are not having a threat with that. But the associated sea level rise can definitely have it can take a toll on the mangroves also when the so-called flooding comes in. Yeah, that is sea level rise. Okay, next question,
So
Setu.
Alina Binoy, you can ask. The floor is yours.
Hello. Yes, Alina.
Alina, she wrote here, but yeah. So she was writing here is like the value added product.
Mm-hmm.
So how it affecting the livelihoods, biodiversity conservation, and climate resilience in coastal communities.
How it is affecting?
Yeah.
Okay. See, we have a lot of valuable products from mangroves, and if we explore and sustainably utilize these value-added products, it is going to benefit the communities. But what is happening is exploitation. Like the other terrestrial regimes and other resources, even the mangroves and their value-added products are being exploited. So that is going to take a toll, because when you continue with your exploitation drive, ultimately you're going to lose the resources and the reserves. So that will affect the livelihoods, because they are much dependent on these. Like, they go into the mangroves and they have a lot of herbal producers, they have a lot of other products, which they are depending long time. So that is where we have to draw the line between exploration and exploitation.
So one more is Girish Krishnan.
Okay.
So Giri Krishnan.
Mm-hmm.
Giri Krishnan, you can ask. A few of
Hello,
them are
ma'am.
writing message. Yeah.
Hello, ma'am. Am I audible?
Yeah, you're audible, Kiri. Please ask.
Yes, ma'am. Ma'am, we do know that like mangroves prefer intertidal zone, but how do we assess that which all species can be planted in the right habitat? Like each species have got different kind of habitat preference, like salinity, temperature, soil
Yes.
characteristics. How do we assess how do we assess to if we are going for a reforestation of
Okay.
mangroves?
Yes.
So
Okay,
how
I
do we?
understand.
Yes, ma'am.
Okay. So for this, first and foremost, we have to carry out a monitoring survey. Like, we have to go to the habitats first and find out like which species is present in which type of habitat. This has to be done for multiple locations. So when we do such assessments, and for a specific period, it's not like that we go study once and come back. We have to do a continuous evaluation. So with this, we can have a statistically arrive at, yes, this is good for this. So only that is the only way out. And we can also rely on secondary data, because see, now we have the so-called spatial tools and AI with us. So once we carry out, a survey, we can apply our spatial tools, we can take out the previous data, and using this ground validation, we will be able to easily arrive at a location. Otherwise, we may have to go on for continue our studies for 2-3 years. No, that is not required. A one-time detailed survey, and on a temporal as well as spatial scale. So when I say temporal, at least 3 seasons we have to observe, and specific locations with, you have to prepare a grid and a map, and you can do an observation. This, when you link with your spatial tools, we can very easily arrive at the site-specific habitats for these.
Okay, ma'am. Ma'am, I do also hear that like Kannur has got more number of species than I don't know if I'm wrong. Please correct me.
Okay.
Some districts have got more number of species
Yes.
compared to like Kollam. Tirundaram has got less number of species. So
Yes.
what may be the reason of this?
See, one thing is could be one reason might be even afforestation. Like, there has been destruction, more percentage of destruction in other areas. Another thing is natural preference. So this is like exactly what this can be answered from your first question itself, like the habitat. So more number of species means it is a more conducive habitat. So if you go to Kannur and Kasaragod, you can see very rich and thick mangroves. So there are two aspects. One is that is a better suitable habitat, which we have to decide based on these surveys. Second thing is limited disturbance has been caused to those areas. So both these factors could be possible. Hello.
Ma'am, one more question. Are there any work done on like pollination?
Pardon?
Like maybe some kind of species will be pollinating the same mangroves. Like, ma'am, maybe some kind of bees or some insects will be helping in the pollination of that, may be resulting in the survival of species.
Okay.
So maybe any work on such topic?
There is no focused research on these, but one-off observations are there. Like, when people carry out small ecosystem surveys, they do make, vague observations or remarks, but otherwise detailed and focused studies on these aspects are not there. So even on the species distribution, we do not have a proper district-wise data. So that is a huge gap. There are huge gaps and lacunae with regard to mangrove studies. So only if we can like address these gaps, we can arrive at scientific solutions.
Yeah, you can ask. Pooja Pradeep, you can ask.
Hello, ma'am.
Yeah, hello.
Ma'am, do you think synthetic mangroves, which is seen as an emerging technology, would
Mhm.
impact the natural ecosystem of mangroves? And do
Okay,
they
ma'am.
contribute
Thank
in the blue carbon market?
Yeah, synthetic mangroves is, of course, an upcoming technique, but again, it depends to be seen how they are going to withstand the so-called climate regime shifts. So that is a huge thing, which has to be like studied and decided because it is just in the emergent phase. And like if you ask me on a personal note, I will always say that that is not always an uh, it's not an alternative for the natural ones. But this is because again this is like the chemical, the so-called chemicals are involved. Like we have the aluminum oxide, etc. And this could have even ecological or environmental consequences. So rather than the the plus side of it, the pros, we may have to face cons in future. So that so on a personal note, I will say no. But like when you think of it in a scientific aspect, yes, there needs to be at least proper research on it when before we can arrive at a conclusion.
Okay, thank you, ma'am.
Okay.
Rahman, you can ask. Yeah.
Hello, ma'am.
Yeah, hello.
Can you share the recent status of mangroves from Lakshadweep? Is there is any work is going on? What's the current status or something
Uh,
like that?
yeah, Lakshadweep actually work is going on. I have not included my slide as such. We have mangroves in islands like Minicoy. So studies are going on with regard to their distribution, etc. But extensive research on this regard is not there. Along with the wetlands of Lakshadweep, a few studies are there on the mangroves also.
Okay, ma'am. Thank you.
Okay.
There is a question from Raki Biswas. So that question is interesting. As a part of our research, we included. So the question is, can invasive species also invade mangrove habitats and affect them? Do they affect the growth of native mangrove species? And what are the main factors that helps in invasion success in especially in mangrove ecosystem like species strays on micro-environmental factors like that?
Mm-hmm. Yes, yeah, I agree with you, Seth. That's a very good, interesting question. Yes, invasives do affect. So we are presently carrying out a survey of Central Weymouth Lake with regard to invasives in these mangrove ecosystems. So what we have seen is like there are quite a few instances like if you take even the Acacia aurum, it is an invasive for that matter, so that is spreading fast. And there are again a few other creepers which you can see coming up on a they are like spreading very fast into the mangrove systems. Now that's with regard to flora. Again, if you take the fauna or the animal part of it, we know all across Kerala coast, especially in the Vemanad Lake system and towards Ashtamudi, we have the issue of Mytilus strigata. So this is an invasive molluscan species which is coming in here. So yeah, of course, it is not going to give a competition to mangroves, but when we speak of invasive, I thought we should mention this as well. This is spreading up fast even in the mangrove habitats, displacing the native species. So the thing is that this is a voracious feeder, so mangroves have rich nutrients. So this is going to grow wild in these areas also. So that is one a huge concern as of now. Yeah.
Ninu, you can ask. Ninu Pushothaman. Yeah.
Hello, good evening, ma'am.
Good evening, Nino.
Yeah, thank you, ma'am, for the wonderful session. And I had a concern, like as you told, as you mentioned in your PPT, the existing mangrove areas are currently under private ownership.
Yeah.
And like we all know about the critical ecological importance of mangroves and all. And there are many ongoing, is there any ongoing restoration projects led by Forest Department or any NGOs along with the Forest Department, like other than WTI that they are doing in Kannur Kandal project? Basically, I belong to Kannur district, so I know about that only. Other than that, I don't have any other information on that. So can
Okay.
you share?
Yeah, actually, there are a lot of programs. Like we have Thiravanam program by the Kerala State Forest Department. So that is a great
Okay.
initiative. And again, MISTI is there. MISTI is the central government program, but Kerala State is also part of MISTI. So
Okay.
we have programs, but yeah, this private ownership is a great challenge. It's a huge challenge, and the only way out may be through incentives for afforestation, which has to again come from the policymakers.
Yes, ma'am. Actually, we are like currently focusing on the existing mangrove species that are there now. Like
Okay.
researchers are going on for that. But to increase the mangrove patch or something related to that, is there anything happening?
Yes, these whatever programs I mentioned, right? Thiravanam and Mishti,
Yeah.
they
Yes.
are trying to increase the patch. Increasing the
Oh,
patch
okay. Okay.
density is the major objective.
Okay. 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 Thank you, ma'am. Thank you so
Thank
much.
you. Thank you.
So, ma'am, in the comment itself, the last question, Hridya KG Caesars Trishur. So, her question is like how pollution by anthropogenic reasons like road construction in area affect the health of nearby mangrove forests.
Yeah. See, that's a nice question, Hridaya, because my team had personally witnessed this when traveling to the Malabar area. So a lot of mangrove patches, they were getting clogged with sediments because during road construction, we all know that there is, sedimentation as well as sediment removal goes on in a parallel way. So during a highway construction, there was a lot of mangrove patches which were buried under the mud and the debris. So that was a sad sight. And another aspect is that during such developmental activities, of course, there will be cutting of the mangroves. So these are the two aspects, which is sadly they are ongoing in spite of all these knowledge on mangroves. It is in practice even now.
Sedu, there is a question in the YouTube also. Do you want me to read out?
Yeah.
Yeah, please go ahead, Anup.
Yeah. There is a question from Harshada.
Mhm.
How the mangrove can be conserved at student level because it is totally different habitat species in biodiversity.
Okay. So, see, students, what I would request all students to do is become ambassadors of mangroves. You cannot go and directly, conserve them, or you cannot go and directly plant them. But awareness is another major thing which you can do. It's a key actually. You make the people aware, you make the communities aware. Like if each student can, share the information to 10 other students and fellow dwellers, that is going to help us because that is the only way out. Community support is essential for mangrove conservation because it is all lined along the coastal regimes where community lives integrated with nature. So this is where we need students as ambassadors of mangroves for awareness. That's the role we can play at large.
Okay, thank you, madam.
Thank you.
If yeah, if any question from anyone, you can ask now. Yeah, otherwise, like now it's my duty to give the vote of thanks. I I hope there are no other questions. Yes. Yeah. Okay. So, dear all, first of all, I would like allow to thank our expert and the speaker, Dr. LimnaMol from KUFOS, Cochin. So it was a very wonderful and a very interactive session. Thank you so much, madam, from CTBC and like from all the participants. Thank you so much for your time and speech. Thank you. And I also would like to thank all the participants in like participated and like came up with the good questions and participated in the discussion and all. Thank you all. And also, thanks to the whole CTBC team who worked hard for this webinar and session. Yeah, thank you all once again. Thank you so much.
Thank you. Thank you so much, CTBC. This was like, a wonderful session. And as you rightly pointed out, it was really interactive. So that makes it clear that, yeah, some messages being passed on and the motive was met. So thank you for that.
Thank you, madam. Thank you all. Thank you so much. സേതു ഉണ്ടോ അവിടെ?
YouTube live it's going on YouTube live. You just
Okay,
cut
okay.
down.
Yeah, I will tell that. Yeah.